Hi, I'm Gregory Charles Herman, a PhD structural geologist living in New Jersey that uses digital geospatial computing and remote sensing to help conduct tectonics and aquifer research. This talk focuses on the tectonic setting and hydrogeological nature of the Peruvian Nazca lines and demonstrates how geology and climate influenced the rise and demise of the Nazca society that flourished when Romans were also engineering aqueducts on the other side of the world. I thank the conveners of session T180, Remote Sensing Applications in Hydrology, for the opportunity to share this research as part of the 2020 annual GSA conference. I read about the Nazca lines as a teen from reading von Daniken's Chariots of the Gods, where he raised the prospect that the strange earthworks seen on the Peruvian landscape could be landing strips for alien spacecraft. Because of their visible and mysterious nature, I began using them decades later to entice students into learning Google Earth as part of college-level physical geology laboratories. I then began virtually mapping the geology of the Nasca region using USGS global data, including regional geology and earthquakes, to assess the tectonic setting using the same methods and tools employed at the New Jersey Geological Survey. Here you will see the Nazca lines are not of extraterrestrial origin, but utilitarian features born out of the need for humans to obtain and manage fresh water in a desert environment. The Nazca lived on the arid western coast of South America in what is now Peru along the foothills of the Andes Mountains. The coast here is a wide, fertile lowland called the Pampas that are the alluvial plains leading upslope to mountain ranges that shed seasonal rainfall shoreward across the region. This oblique northwest view is shown using 3 times vertical terrain exaggeration. You may have already noticed that 2 spellings of Nazca are used here. Archaeologists and anthropologists spell the human culture using S, whereas geologic, geographic, and non-animate objects are normally spelled using Z. Therefore, I will follow suit by referring to inanimate ones using Z. The Nazca, like their Roman and Hopewell contemporaries, flourished through a favorable, cool, wet climate cycle that lasted 500 years at the onset of the formative archaeological period, before a series of droughts spanning 200 years likely brought societal collapse. The temperature anomalies charted at the bottom are based on ice core, lake, and ocean sediment studies detailed in Wikipedia under the entry Holocene Temperature Variations. The Nazca used artistic motifs to communicate cultural aspects with icons, patterns, and figurative activities depicted in earth tones on ceramics and in textiles. Archaeologists arranged the iconography into early, middle, and late thematic stages named proliferous, including naturalistic motifs in zoomorphic and phytomorphic forms, transitional, having agricultural, religious, and mythical motifs featuring anthropomorphic beings with elaborate and abstract ornamentation, and lastly, monumental, having militaristic and ceremonial themes, including geometric circles, bands, and cross-hatched lines, and the common use of trophy heads. The line sequence is congruent with these temporal and thematic artistic stages. The geoglyphs are earth markings in the form of shallow trenches or raised berms and mounds with up to 60 centimeters relief and large areas cleared of soil and stones. Visual contrast results from moving aside the dark, weathered, reddish-brown pebbles and gravel to create channels floored by lighter-colored layers of yellow-brown, silty sand and clay subsoil. The oldest and most dense occurrence of glyphs occur along the south bank of Rio Ingenio, where freshwater seepages were first ponded in agricultural paddies shaped with naturalistic motifs, then successively overprinted in time by the expansion of geometric channels, fields fed by the wells, and the piquos, aqueduct, recharge, and maintenance portals. 3 geoglyph classes include figurative biomorphic lines, geometric lines, and polygonal areas called campo burritos. The dating of geoglyphs isn't absolute and is currently based on radiocarbon dating of associated archaeological artifacts. Early studies concluded that they were sacred paths associated with aqueducts and cemeteries, with later studies showing poor correlation with astronomical alignments. The area was designated a United Nations World Heritage Site in 1994, and the lines continue to be studied and debated today. By adding spot elevations at line intersections and radial centers, it becomes clear that the geoglyphs are indeed ditches and cleared fields that are part of crop irrigation circuits moving water down slope. Using geological cross-cutting relationships, 3 stages of line development are seen. This example shows two avian naturalistic glyphs cut and overprinted by linear channels, then later Campoburitas. Early figurative glyphs are locally incorporated into later flow schemes but obliterated elsewhere. But these pampas glyphs all possess flow-through designs or irregular berms that would pond water flowing down slope. Another example of line succession is seen where an early hummingbird glyph gets overprinted by irrigation channels that are both overprinted by Campoburitas and even later channels. Note the down gradient flaring out of the Campoburitas in the northeast upper right corner from a central point where a circular feature is likely a mound or a well. Part of the Peru 1 to 100,000 scale Nazca geologic map is shown here as an image overlay in GE. A recent hydrologic study in the area by Johnson and University of Massachusetts geologists also noted the spatial association between the lines, aqueducts, and concealed faults that channel groundwater flow. Rivers and streams of the Rio Grande fault system follow deeply weathered fault segments that branch off the main fault routed seaward and flow landward and up section where they are concealed by recent alluvium. The Rio Grande fault system rests directly on top of the subducted Nasca Ridge on the active convergent oceanic continental margin. The ridge is a thickened segment of the Nazca Plate that's drifting beneath South America at a rate of 50 to 60 millimeters per year. The Nazca Plate is otherwise bounded by oceanic spreading centers where new crust is generated along the East Pacific Rise. A suspected Nazca impact crater lies at the plate's center that likely resulted from a large fragmented asteroid that struck along a southeast to northwest heading with an oblique trajectory about 24 million years ago. The Nazca Ridge has been drilled twice by the U.S. Ocean Drilling Program and has seafloor elevations reaching roughly 1 kilometer higher than surrounding normal oceanic crust. Note where regional cross-sections A and B are developed. Regional cross-section interpretations depict the Nazca Ridge relative to regular oceanic crust, the Nazca Pampas, and Andes Antiplano. The top section shows the Nazca Ridge as a thickened crustal segment from impact-induced fracturing of the lithosphere and secondary plutonism. The bottom section shows subduction of the Nazca Plate and ridge beneath the Pampas that isostatically raises the Andes Antiplano. Note the location of section DD' where the Rio Grande drainage is mapped. Looking down on the drainage from 88 kilometers altitude, we see the Rio Ingenio and Rio Nazca major tributaries and the yellow area encompassing about 200,000 acres of the Nazca earthworks. The lines here include black faults and colored lines of equal elevation from 300 to 2,000 meters across the region, with most cultural activity focused between 400 and 500 meters. The Nazca Aquifer is labeled along the south bank of Rio Ingenio, where the highest concentration of geoglyphs occur. The earthwork falls exclusively on the northeast limb of the depression de Ica Nazca, the structural keel of a regional synclinorium where shoreward strata dip northeast and mountain strata dip southwest. A series of quaternary alluvial terraces and fans rests on gently dipping and fractured sedimentary and volcaniclastic bedrock of the tertiary Changuilo Formation that together comprise the hydrogeological framework. The recharge potential of aquifers on the northern limb is greater than the shoreward limb because of alluvial fans and bedrock strata that are suitably situated to efficiently transmit groundwater downhill. Local cross-section interpretations depict the Nazca Aquifer as a thin blanket of alluvium atop bedrock dipping into the depression de Ica Nazca. Note how crustal faults branch and splay upward from more deeply rooted larger ones, and how bedrock layers that dip off flanking mountains are prone to both surface drainage and groundwater infiltration, leading to the depression and the perched Nazca Aquifer. Here we see a bare ground expression of the terraced alluvial fan with a modern aqueduct highlighted yellow near the base of the Changuilo Formation and the concentration of older naturalistic glyphs traced in green. The lines fall mostly on the alluvial fan, and the aquifer is located near the fan apex where up-gradient portals were developed to charge down-gradient fountains. Hydrologic profile EE' was developed through an area having many geoglyphs. A web-based geological mapping tool developed at the NJGS in 2015-16 was used for this project. The tool uses aerial imagery and digital terrain data from NASA's Whirlwind Earth Globe to virtually calculate the strike and dip of stratigraphic bedding in adjacent fault blocks. Geologic planes seen in imagery can be traced at 3 points along their intersection with the ground to determine their orientation and plot 2D or 3D oriented symbols that are compatible with GE. As seen in section, the gentle southwest dips of beds parallel the direction of water flowing off the mountains. From Appalachian aquifer research, we know that groundwater flow is semi-confined at the base of superficial strata, and down gradient flow and bedrock dipping subparallel to topographic grade produce artesian flows when semi-confined bedrock layers are tapped by wells. When the Nazca section is aligned with the cross-flow example, we see that the Nazca learned to recharge and tap semi-confined alluvial beds with artesian wells dug down gradient in fields at the centers of radial hubs. Flow of pore water in saturated media is driven by gravity from positions of higher total head towards positions of lower total head. For the Nazca Aquifer, as seen in section FF prime, about 13 meters of hydraulic head over a 1,400 meter run results in a very low hydraulic gradient and slow natural flow velocities and seepage discharges that were compounded using shallow artesian wells dug into Campo burritos to irrigate fields and distribute water for prolonged periods through what archaeologists have called starburst glyphs. On a final note, an unexpected archaeological aspect of this work surfaced from the remote visual scrutiny of the line extents. A mountain ceremony site was discovered with complex geoglyphs situated on top of a foothill directly overlooking the Nazca Plains to the south. Whirlwind imagery helped make their forms clearer. This find raises interesting questions regarding the northern Peru Moche and Nazca interaction during their monumental stages, because this Nazca oculate being and owl are depicted together in a ceremonial setting similar to iconic depictions of the Moche warrior and owl priests. The central trapezoidal field atop the hill may have served as the battlefields depicted on Moche pottery. Nazca depictions of warriors, warrior deities, and their battle arsenal and ceramics share thematic similarities with the mountain geoglyphs. The design of battle clubs, taking of trophy heads, and priestly habits appear very similar to those of the Moche, who used more elaborate and descriptive ceramic iconography depicting an owl priest serving a chalice of blood taken from a captive to the high warrior priest. Note how the mountain ceremony site central field resembles those depicted on Moche warrior bottles having opposing warriors and battle clubs centered in context about the trapezoidal competition venues, sharing geometric similarity with some Campo burritos. To conclude, the tectonic agent giving rise to the Nazca lines is subduction of the Nazca Ridge that was generated by the Nazca impact event, estimated to be about 24 million years age, based on core from ODP site 1236 showing massive climatic shifts and sea level changes beginning at that time. This has been an ironic experience, having been introduced to the lines where the specter was raised of their UFO extraterrestrial origin, only to realize a half-century later that indeed an extraterrestrial agent in the form of an asteroid shower probably staged their rise. But ultimately, it was man's quest to discover fresh water in desert oases capable of sustaining communities that drove the Nazca to utilize and innovate what they found into the mosaic earthworks that remain for us to ponder 2 millennia later. Leave it to climate change to end the Nazca, which concludes this talk. Thank you for tuning in.